about revenue last time. Alrighty. Companies' revenue, as we know, revenue depends on your price. Okay, we know that. It also depends, your price can affect how much you're going to sell. Right? We talked about this idea that if we are trying to sell t-shirts for $500, you might be like, well, man, we'd make so much on a t-shirt if they were $500 each. Yeah, except no one's going to buy a t-shirt for $500 from us. Okay, maybe Kanye would or something, I don't know. Okay, so you have some revenue equation. That being said, right, so revenue depends on price, and how much you sell depends on how you price it. Okay, you could sell a lot for really cheap, but then if we sell our, again, like we talked about, if we sold our shirts for 10 cents each, we wouldn't make we would be in the negatives, I'm sure of it.
We'd be rolling in dimes.
Except, right, shirts cost us $6.50 plus shipping, and so that's not probably a very good idea. Okay, so let's suppose this is some company's revenue equation. Okay, that's their revenue equation. My question is, what should the price, which is P, what should the price be for the maximum? I would. So that when you look later and I ask a similar question, you're like, oh yeah, that was how I answered that question. What should the price be for the maximum revenue? First question. Second question, what is the maximum revenue? Can we stop for a second? Hat. Thank you. So, spoiler alert, what shape is this graph going to make? Parabola. How do you know? Okay, valid. Because that's what we're learning about, because we did it before. No, that's fair. Those are valid points. That's fine if that's how you know. P squared, right? Anytime you have a P squared or an X squared or J squared, whatever, squared, that's the sign of a parabola. Okay, that's your hint that it's going to be a parabola. So it's absolutely going to be a parabola. So what point on the parabola are we looking for? Just as a spoiler. What, Rodney? Yeah, the maximum, right? It's probably going to be an upside down parabola, and you're looking for the maximum or the vertex. Okay. So you're not going to be able to do that in your brain. You probably need a calculator. Right? This actually could model close our t-shirts. We talked about this last class. I'm going to emphasize it again, that we don't know our demand, right? Big corporations and businesses, they have research and market research departments that figure out through research like what the demand for a specific product would be based on the price, right? How many people would buy it if it was $10? How many people would buy it if it was $12? How many people would buy it if it was $20? Okay, we don't have that, right? So we can't figure out our demand equation, and we'll talk a little bit more about that. But this could potentially be something that was modeling our t-shirts. Okay, so let's think about our t-shirts first of all. What are these numbers along here? What are these X's, or in this case P? What are they? What does that represent? Given this equation, what's the P?
Is that our starting point?
What was the first question that you can't see anymore?
What should the price be?
Right. What should the price be? Right? The P, this X here, is the different prices. This is telling you, okay, if you sold it for $0, you would make $0. That's, hopefully we kind of get that. Like you wouldn't bring any money in. Okay? If we were selling t-shirts and we're talking about price, right? Is it going to go all the way up to like 100? like realistically, you think we could sell a t-shirt for $100?
Yeah.
Our t-shirts.
No.
Okay, no, right? Realistically, this isn't going to be around 100. So let's kind of think through that. When you're making your x-axis, are we going to sell our shirts for negative dollars?
No.
No, okay, and we're probably not going to sell our shirts for negative or for $100 either. So this number shouldn't be anything crazy. If your x's are going to like the thousands, too big. Okay, this is the price, and for a given price, what does it tell us? What is this equation about? What's the R for? Revenue. What's revenue mean? Like income, but for a business. Okay, revenue is how much you make. So think about these numbers. Do you think if we sold a bunch of shirts, we're going to make 10 bucks? At least, sure. This number should be pretty big. We're talking about revenue. Okay, so the part where you're finding your graph, the part where you're trying to find your window takes a little bit of finesse. We're going to get better at it as we do more of these, but I'm not giving it away the window. So keep working until your window, you can see all those parts. Okay, keep working with it. See anything. So on my window, remember, X's are the P's. It's the price of a shirt. Are you going to sell a shirt for negative $10?
No.
No, $0 at least. Okay, and for max, think about what's going to be the max price of a shirt.
20.
15, maybe 20. I don't know. Like
20.
we could maybe sell a shirt for 20. Not a lot of people would buy it. 40.
It depends.
Okay, risk it. 40. So that's our price. This is what we're looking at. We're looking at, okay, our price is maybe somewhere from 0 to 40. Okay, revenue, the money we bring in, how much money we make. Not talking about expense, right? I'm not talking about what we spend on our equipment and all that stuff. I'm talking about what we bring in. The least we can bring in is $0. Right? This would be pretty bad news bears, of course, because we know we have expenses. But at least our revenue is going to be $0, right? And if we think about how many shirts we've sold this year, does anyone know how many we've sold?
Too many. Too many.
I would say we sold close to like
More than 700. Remember that one big order?
really large orders.
Okay, so let's say we sold them.
5 million.
Let's say we sold 500 to take it 500, and we sold them at 10 bucks a piece. How much would that make us?
$5.
500 at 10 bucks a piece would be $5,000. Okay, I don't know if that's right, so I'm just guessing. So here, this is saying our price is between $0 and $40. Our revenue maybe upsides of 0 to 5,000, and then we get a nice graph. Okay. Yes, but it will get easier as we practice. It also will be easier once we understand what the X and the Y are, the price and the revenue. Once we kind of start understanding that, it'll be a little easier. Okay, so here, there's your window. 0, 40, 0, 5,000. We need to find the maximum. Raise your hand if you already found the maximum. 1, 2, 3. Okay, everyone find the maximum. Work on that piece now. Now that we have the window, find the maximum. Hint, it says it's the one that says maximum on it. Second calc.
I did something wrong.
Yeah, check your window.
Wasn't it 0, 4?
B. 40.
And then 1, 0, 5,000, 0, 1.
1, 1. At the bottom. The left of your vertex, hit enter. Go to the right of your vertex, hit enter again, and it tells you your maximum. Okay, so let's talk about this point. What does 15 mean, or 14.99998? What does that mean in terms of our problem? 15, what is that? Okay, the maximum price is $15. And it's saying if we sold the shirts at $15, what would our revenue be? This, right? $4,500. Now we talked a little bit about that for right now, for our stuff, right, this is contrived. We don't know our demand equation. Okay? So once we find that maximum, the price was our x's, and the revenue, how much we made, was the y's. Like we looked at last time. Okay. $15. Okay, ready for another one? Okay, we're going to see if we can do a little better. Next one. Someone had some made and never sold them, so we are. So these are window clings. They're different than stickers because you can put it on your window and then take it off later or whatever if you want to. Okay, it's like a static thing. And yes, we will be making them in the weeks to come. More on that with the new printer.
What are we gonna do? Like,
more on that later. But, okay, talking about window clings, right? Again, thinking about just like using some reasoning first of all. Right now, we sell these for $1. That's just a price we made up. Sell them for $1. Okay, how much do you think? What's the max that people are probably going to buy this for?
30.
Okay,
$1.
for maybe 5.
125. 128.
Okay, probably not $30.
30 cents.
$10.
Maybe 30 cents. Right? But people are probably not going to buy this for like $10.
$1.
Okay, maybe one person might, but whatever. So when,
That's what we're
wait, look. When you're choosing your price, your window, right? When you're choosing your window on here, you probably don't need to go from 0 to 1,000 on your x-axis because your x-axis is the pricing, right? You like maybe, I don't know, 5, 10, I don't know what it is, but it's probably not going to be something crazy because we're talking about window clings, okay? And let's suppose, right, if it was like $5, okay, I don't think we're going to sell a bajillion of them. All right, so your revenue is going to be higher. Your Y's are going to be higher. Okay, graph this equation, and now let's see if we can dial that in a little bit. Are we any better at finding the window here? And then finding the maximum. Maybe we can try and do this on our own this time. I'm going by ones. What is this number right here?
like 8, 10.
I'm going by ones. Look at my screen.
1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9.
Okay, this is 8.
8.
1, 2, 3, 4, 5, 6, 7, 8. Okay,
Was that 9?
it's 8 still. So 8, what does this, now I want to talk about what does this mean?
$8.
$8, and what happens at $8? Why no one buys any? No, but how do you know that? Because at 0, it's down, and it ended at 0. It's a root, nice.
Nice, using the big words. That's
Okay.
cute. Okay.
Root's technically a little word. Okay, so this price would mean, right, $8 for that window cling, no one's buying it. Okay, it would mean no one buying. Okay, here, $7, there's a few people, $6, $5, $4. At $4, that's the sweet spot, right? Okay, that's saying here, that would be our maximum. And we could find that point out. You don't have to go that far.
I think you should go back. See, I got that too.
At $4,
$4.
the max revenue is 160. Okay? Again, this means, hey, if I'm talking, you shouldn't be.
Yeah.
the maximum revenue is $160, right? That's what this point means. It means the X value means that's the price. When we're selling them for $4, that would be when we make our maximum revenue. Okay? And there is a limitation, right? We know we're not going to sell an infinite amount of shirts. Even if we look at our market, right? Eventually, everyone who wants one's going to have one, and then we're not going to be selling them the same amount. Okay, on 2? Now on 3, let's make sure. Lots of you might be tempted. You might be tempted to square root right here. The 3 is not being squared. You cannot square root it because it's not being squared. This says 3 times x squared, yes, so the opposite would be to divide both sides by 3 first. We get our x squared equals 25. And from there, of course, we're okay. We square root. Great. Positive negative 5. Yes. Now I'm going to skip 5 and go to 6. Because here's the issue with 6. You guys are so well trained to see this. And what do you think you should do with that 3? Distribute it, right? Before we talked, right? Multiply it, distribute it. Now, this is why sometimes math loses people. Because if you don't pay attention to what I say right now, then the rest of time you're going to be hurting. Okay? This, and this are 2 completely different things. They have completely different meanings. Like they're not even close. And this is a tiny little 2. And what some people do, they say, if I don't write that tiny little 2, is it wrong? Yeah, because it's like extremely important. Right? It's a tiny little thing that changes everything. You guys know that Mio commercial? No?
Yeah.
Okay, changes everything. The water thing. So I cannot distribute here because of that square. I cannot distribute. The reason I cannot distribute is because of that 2. Right? So, maybe you're like, oh, it's squared. I should square root the whole thing. But again, go Paul, you cannot square root because the 3 is not being squared. Right? Yep. Right? This is being squared, but the 3 is not. So since this says 3 times all of that, yes, the opposite of multiplying is dividing both sides by 3. So all we do there, you don't type anything in. These guys, what's 3 over 3?
0.
Don't say 0. Whoops. 3 over 3, anything over itself, right? 3 divided by 3 is 1. The reason we're doing that is so that these 3's cancel each other out. I don't divide the 4 by 3. I don't do anything crazy. They just are gone. They simplify. I'm left with x minus 4 squared equals 12. It's 12, yes. Yes.
And then you square root it.
Yes. And now our problem looks like number 5. Okay, it looks like number 5, so pay attention. Now it's squared. So how do I undo a square? Square root it. What's the square root of 12?
3.46.
What did you say? 3.46. Your calculator is only half as smart. What's the real square root of 12? Positive and negative this. So right here, just like number 5, what's the square root of 9?
3. Negative and positive. Positive and negative 3.
2 equations. 2. Positive 3, negative 3. It splits into 2 equations. So that when you finish solving, one of your answers for 5 is 1, but it's not just positive and negative 1. It's 1, and then over here, you get a completely different answer of negative 5. Completely different answer. Okay, not just positive and negative 1. So that's how you do number 5. And it's similar for 6, except you have ugly numbers. Yes? Yes? I'm not talking about that part yet, though. But it's good for you to know. Okay, so again, for 5, we get 2 different answers, 1 and negative 5. For 6, we're also going to get 2 different answers. They're not going to be as pretty because the square root of 12 is not a nice number in integer. But same thing, positive 3.46, negative 3.46, and then you can finish solving. Ready? Finish it out. 7.46. Anyone know what negative 3 plus 4 is?
0.54.
Ooh, you did it already. Nice. Not 1.46.
I got negative.
Nope.
4.54.
Nope. Check again. If you owe $3.46 and you give the cashier $4, they give you 54 cents change. Okay, great. Is anyone here feeling extra smart today?
Yes, me.
Yeah? Okay, Yolanda. Yolanda, listen. Ready? Yolanda's going to help us. Come on, gosh. Yolanda, what is, listen close. Don't interrupt her, and no one else say it, okay? What is, Moises, don't tell her. You know this. What is 100,005 times 0? Oh my gosh, boom. Okay, say that again, Yolanda. 1,105 times 0 is what? Is 0. Chris, if you don't shut your mouth, I'm going to kick you out of here. Okay? Andrew, what's 1,590 bajillion times 0? 0.
No, it's actually 0.
Okay? Luis, what's 8 times 0? What? What? 0. What happens when you multiply something by 0?
It goes up by 1.
Okay? When you multiply by 0, you get 0. Now here's you get a black hole. Okay. Here's your task.
Oh, I used to do that back in Rome.
The answer is 0. That's $1.
Here's what you get.
Oh, I know.
Yeah, don't put that down.
No, we got it.
He said no.
Okay? Find me 2 numbers that multiply together to be 0,
I know.
but neither of them themselves can be 0. Also, before someone tries to get cheeky, negative 0, not a real number.
Wait, so we
Okay.
can't use 0.
Okay?
But you can't use 0, so.
Right. So find the 2 numbers that multiply to give you 0. If you need calculators, go ahead. Yeah.
I feel like.
Yeah, the point is that it's nothing.
But it could be anything.
Okay? No. It's nothing.
That's deep.
Okay? Right? I'm not trying to trick you. I'm trying to convince you of the fact that if you have 2 things that multiply together to be 0, what does one of them have to be?
0.
0. It has to be, right? It has to be. Okay? Yeah. I know, and you didn't spend any time trying. I know, and that's the point. Quinn, I know. Okay, great. Quinn and Chris, you guys are the exception. That's great. Okay. Like I'm ever going to give you $1. I actually won $1 from someone in 5th period, so that's what the $1 was. See, and I got some IOUs too. Go, Paul. So here's what this says in the middle of your paper. If you have two things, whatever they are, A times B, and they equal 0, either A must be 0, and B could be anything you want. It could be a bajillion, 100,000, 5, -8, Google, whatever. Or, right, so if A is 0, B can be whatever you want. Or, other option is that B is 0. But one of them is going to have to be 0. There is no other way to do it. This has a special name. It doesn't matter which one's 0. That'd be cooler, actually. Not that cool. I would like to call it the 0 effect. I'm going to rename it.
Only 0.
Not as cool of a name. Mathematicians aren't very creative. Hey, go Paul, will you go back to your seat, please? Or Dominic, or whatever. What are you? Yeah. Sassy, thanks. Okay, this is called the zero product property.
Why?
Listen. Because what does the word product mean? Oh, don't think of business. In math. Multiplication. Is this talking about the property of when you multiply by 0? Yes. Right? It's talking about multiplying by 0 gives you 0. Right? When I was really young, I used to tell my older brothers that I was smarter than them. And I have a specific memory of them telling me, oh yeah, you're so smart all the time. What's 5 times 0? And I just started crying because I didn't know. Okay? So, yeah, I showed them.
What is 5 times 0?
5. Oh, dang.
That's not funny. That makes fun of his salty. It's actually salty. I'm a B2. I'm a B2 up.
Almost broke it. Okay. I don't care so much that you know what it's called. Don't really care. What I really, really, really care about, though, is this. I will say this until I'm blue in the face. Look. Two things that multiply together to be 0. Solve this in your head for me, please. Look. What can go there that will make x minus 4 0?
4.
0 minus 4 is 0?
Negative 4 minus 4. Positive.
4. Positive 4.
Told you. Oh my.
Okay, 4. Ready? So the answer is 4. That's pretty obvious. What about here?
2.
Okay, here's how we show that, right? We could look at it and be like, yeah, if I plug in a 4, 4 minus 4 is 0, and whatever is under my finger, it doesn't matter if it's a giraffe, 0 times that is going to be 0. Okay? The way we show this in the zero product property is similar to number 5. It's similar because we're going to say either this is 0, right? Either x minus 4 equals 0, or your other option is that x minus 2 equals 0. Do I have to show that step, Miss Dolte? Yes, you do. Okay? Showing either the first one's equal to 0 or the second one's equal to 0. The fact that this number is 0 is hugely important. If you had this, doesn't work. Nothing you can do. Because there's a bunch of stuff that multiplies to be 10. Not special. 10's not special. 0, super special. Okay?
Why is 0 special?
Because it has to be 0. Okay? Look. Look. Luis, pause. So how do I solve? What's the opposite of minus 4? Look, we already knew this. Shh. We already knew the answers for. We're just checking. Okay, we're showing that thought. Good call.
Oh.
Right, so here, now we can show, this is how we are showing the thing we already knew in our head.
Because we're smart.
Okay, so that's a big piece of math is like, can I communicate what I'm thinking mathematically? Can I communicate that? Okay? So, I like the thing where you said you'd talk later. That was better.
Oh, I'm talking to you.
Okay.
I said if I could just.
So, 8, 9, and 10. Okay, 8. 8. We should have come up with 5 and negative 7. Hunter. P for pause. Hey, I will talk to you guys for 2 more minutes. If you could be quiet, that'd be great. 2 more minutes. Okay? Some people on number 9, you're like, what? Things are getting crazy now. It's not too bad, though. Because again, same idea. Either this first thing, parentheses, has to be 0, or your other option is that x plus 80 is 0. Those are your two options. And really, just because there's an extra step, maybe that was a little harder for you to solve if you just try to do it in your head, but still possible, because if I'm looking at this equation, how do I solve it? What's my first step?
Plus 6. Plus 6.
Andrew, be productive. Plus 6, and get 6, and then what do I do?
Divide.
Yep.
Which gives you x. And you get 1 over x.
Okay, and I get 3. Okay, so it's not too complicated.
Confused on the x plus 7 equals 0. How do you get 0?
This?
And the x do the same one too, because that way.
For this?
Yeah, it's easy.
Because again, I'm setting this equation up to say that this x plus 7 equals 0. And this is what you were kind of talking about, Yolanda. You're like, well, wait, what? Like, if I'm adding up to 0, if I think about it, that means I'm starting behind 0, right? That means I'm at a negative 7. So when I add 7, I get to 0.
Negative 7?
The answer is yes.
So negative 7 plus 7 is 0.
Yeah. Okay. And again, on number 10, both of these are a tiny bit more complicated. Again, because it's equal to 0, and you have two things that multiply to be 0, you have two equations. Both relatively simple. 5x plus 35 is 0. Or the other option is that 3x plus 2 equals 0. And just like we did on number 9, to finish out solving, I would subtract and divide. Negative 7. Okay. And over here, hey, can you guys keep it together, please? Divide by 3. I'm going to leave my answer as a fraction because it's easier. Instead of writing, you know, a never-ending decimal, I'm not going to do that. Instead of doing a never-ending decimal, I'm going to leave mine as a nice little fraction. Okay. No, that's ugly. It is this. Okay. So here's the deal. Most of you will have time to finish your homework today in class, which will be nice. When you are done with 11 through 16, I'll give you your homework. You might want to work smartly. You can help each other, do whatever. Do not copy. Do not copy. When 11